Welcome once again. I want us to look at two dice that are rolled at the same time. And after rolling these two dice, we observe the numbers that appear on each die. And then we add those two numbers together. So our outcome is the sum of the numbers when the two dice are rolled. So let's suppose that one die shows us a 1 and the other die shows us a 1. So when you add a 1 and a 1, you'll get a 2. If one die shows a 2 and the other one shows a 1, the answer will be 3. One die shows a 3 and the other die shows a 1, the total or the sum will be 4. That shows a 4 and a 1, so we get a 5. That is a 5 and a 1, so we get a 6. That's a 6 and a 1, so we get a 7. So let's come here now. In this case, that die is showing a 1 and this die is showing a 2, so the sum will be 3. You see that? Here, that die is showing a 2 there, and this one is showing a 2 here, so that gives us a 4. For this one, it will be 3 plus 2, which is 5. That one will be 4 plus 2, which is 6. You will notice this is 5 plus 2, which is 7, and that is 6 plus 2, which is 8. Right, hope that is clear. In this case, that die shows a 1, that die shows a 3, so we get a 4. This one is a 2, and that one is a 3, is a 5. So that's a 3 and a 3, we get a 6. That's a 4 and a 3, we get a 7. 5 and a 3, we get 8. 6 and 3, we get a 9. Hope that is clear now. So let's complete this very quickly. That one will be 6 here. That's 7, that's 8, that's 9. That is 10, that's 11. Then this one here will give us a 7. You see that? That's a 1 and a 6, so that's a 7. That will give us 8. That gives us 9. That gives us 10. That one gives us 11. And that one gives us 12. Right, so how many times did we roll these dice? This here will tell us how many times the dice were rolled. Altogether, this was 36 times. Okay. So remember, our outcome is defined as the sum of the two dice, or the sum of the two numbers that appear on the dice. Now, we want to look at the probability that the sum will be equal to 2. That's where we are here. So again, you can think in terms of relative frequency. How many 2's do we have here out of a total of how many outcomes? So we said we have 36 outcomes altogether, but do you see that we have only a single 2 there out of the 36? So we get our answer here as 1 out of 36. Then for the 3, there's a 3 here and there's another 3 there. So there are 2 of these out of a total of 36. So the answer is 2 out of 36. Then for the 4, there is a 4 there, there's another 4 there, there's another 4 there, altogether 3. So that's 3 out of 36. Then a 5, there's a 5, 5, 5, 5, 4 of them. So that's 4 out of 36. What about 6? There's a 6 there, a 6 there, a 6 there, a 6 there, a 6 there. Altogether, we have 5 of them. So there is 5 6's, so it's 5 out of 36. Then the 7's, 1, 2, 3, 4, 5, 6. We have 6 7's, so it's 6 out of 36. And then 8 is 1, 2, 3, 4, 5. Right, 5 out of 36. Then how many 9's are there? 1, 2, 3, 4. So that's 4 out of 36. How many 10's are there? Only 3. So that's 3 out of 36. How many 11's? We can see there is 2 out of 36. And how many 12's? Just 1 out of 36. All right. So it will be interesting also to just add these numbers. What is 1 over 36 plus 2 over 36 plus 3 over 36 plus 4 over 36 right up to the end. The denominators are 36, so you can just add your numerators there. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 will actually give us 36. So just check that. In theory, we actually expect this thing to happen like that. Now check here, which sum appears most. You can check from the table there. This is called an outcomes table. The 7 there is appearing 6 out of 36. And 7 is actually the highest number that we see. That is our mode, the most frequent answer that we get there. Why do you think 7 is appearing more than any other number in theory? And why do you think 6 and 8 will be the next numbers? Because they appear 5 times each, followed by 5 and 9, followed by 4 and 10, followed by 3 and 11, followed by 2 and 12. Why do you think that is the case? I want you to think about that answer. Right, so what we want to check now is what happens in an experiment. So let's roll 2 dice 36 times. And we're going to record on this table here the sum of the numbers that show on the 2 dice. We know that the minimum will be at 2 and the maximum will be at 12. So we're going to do an experiment now. Let's go to our GeoGebra where we can roll our dice. I need 2 dice, so that's fine. And I'll do this 36 times. I think I'll do it just one at a time until I get to 36. That might take a bit long. So this is the first thing that happens. The thing is, in this first roll, we are getting a 2 and a 6, which gives us a total of 8. And so that is why 8 there is now appearing once. So that is the first toss. We'll record this later on. So let's go up to 36. So that will be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So there we are. That is 36 of these. And we actually got, in this case, we didn't get a sum of 2 at all. So no 2s here. But how many 3s did we get? So we got 3 of these. How many 4s did we get? That is 5. 5 4s and 2 5s and 6 6s and 2 7s, 5 8s, 7 9s, 1 10, 1 11, and 4 12s. All right, let's just record that for now. Let's put it here. So this is what we are getting here. And suppose we use this to work out our experimental probability, that will then be our relative frequency. So the probability of getting a 2, we just need to check all together here. We actually have 36 numbers. So if we add all these numbers, 0 plus 3 plus 5 plus 2 plus 6, up to the last one, that should give us 36. So we have 36 of these numbers. So the probability of a 2 is the number of times we got a 2, which is 0 in this case, divided by the number of times we rolled our dice, which is 36. Then for the 3 3 appeared 3 times out of 36. And we got a 4 5 times out of 36. And we got a 5 twice out of 36. We got 6 6 times out of 36. 7 appeared twice out of 36. 8 appeared 5 times out of 36. And 9 appeared 7 times out of 36. 10 appeared only once out of 36. 11 only once out of 36. And 12 4 times out of 36. But compare the experimental probability to the theoretical probability. Check what happens if I were to do this many times. I'll just increase these numbers. You will notice now that the 7 is actually leading everything. The number of 2's and the number of 12's are almost the same. We saw that from the previous thing. Like if you look at this, we said the number of 2's will be 1 in theoretical probability. The number of 2's will be 1, and the number of 12's will be 1. The number of 3's is 2, and the number of 11's is 2. Number of 4's is 3, and number of 10's is 3, and so on. So there's that kind of symmetry there. You will see that pattern in this experiment. As we increase the number of rolls, we get the number of 2's and the number of 12's almost equaling each other. The number of 11's equals the number of 3's. They're not yet equal now, but as we increase the number of times we roll our dice, that should actually be observed at some stage. And the number of 7's will always lead. Now you can go back and answer the question, why is 7 actually leading? Why do we have more 7's? And why does our shape look like that? That looks like a normal distribution. It's symmetric, and our symmetry is there at 7 there. All right, so I need you to think also about how you get an answer of 7 in order for you to try and answer this question. But I hope you see now, as we increase the number of times the die or the dice are rolled, we will get a shape like this. And if we work out the probabilities, we will get more or less the same answers that we got for theoretical probability. The probability of getting a 2 will be 1 out of 36. The probability of getting a 12 will also be 1 out of 36 if you continue with this kind of experiment. I hope that is clear.